2:17 a.m., Tsushima Strait. The sea is a black pain, the moon a peeled coin. A Gato-class submarine lies at periscope depth, engines at a low, oily murmur, air in the control room tasting of batteries and coffee. In the green glow of the scope repeater, a convoy resolves from static into geometry, a columned procession of tankers and freighters, blacked out, bows slicing the Kuroshi's cool skin, gun flashes on the horizon where an escort chats with phantoms. In the forward room, 6 steel torpedoes wait behind their caps like held breath. The order is whispered more than spoken. Stand by. Fire 1. The boat recoils, a felt shudder through deck plates, then a second, a third. Under the surface, white lances curve toward math. Estimated speed, angle on the bow, bearing rate, spread. The wakes look like chalk marks under glass. Freeze frame on that last wake. Title card. Japanese were stunned when American submarines launched 15,000 torpedoes. Now widen the lens. This is not a single ambush. It is the distilled logic of an entire maritime war waged in the dark, a campaign that turned the world's largest ocean into a ledger, torpedoes expended against tonnage removed, convoy miles against patrol days, industrial calories burned in US factories against calories denied to Japanese engines. The wake we froze is one line in a vast arithmetic problem whose answer rewired the war in the Pacific. The American silent service, never more than a few dozen boats on station at any given time, pursued a campaign that grew from frustrating impotence to industrial lethality. Early patrols were haunted by silent detonations and premature explosions. Late war patrols wrote the death certificates for Japan's fuel supply and coastal trade. Over roughly the length of the war, US submarines would fire on the order of 15,000 torpedoes, each one a hypothesis launched into black water, each one asking the same question: does engineering, training, and information beat doctrine, courage, and myth? Start with the submarine itself, a machine designed around a single problem: get a fire and forget weapon into the side of a ship that doesn't want to be hit. The platform must do 3 jobs: find, approach, and solve. Find was increasingly a radar problem. Surface search sweeping for metal in the night, aided by traffic intelligence and careful knowledge of sea lanes. Approach was a geometry problem, closing to an angle where torpedo gyro settings and target course combined to produce acceptable hit probability, often requiring an end around, the surfaced submarine sprinting in a moon shadow to get ahead of the convoy. Solve was a computation analog, continuous and unforgiving, fed into the TDC, the torpedo data computer that turned bearings and speed estimates into gyro angles and firing sequences. Each step had its own failure modes. Each step was only as good as the torpedo you finally committed to the water. A submarine might take a week to reach patrol grounds, a day to find a convoy, and 10 seconds to send a spread of 4. Hit probability at practical ranges rewarded redundancy. 2, 3, even 6 fish, offset deliberately to bracket misestimation error. Multiply that micro-pattern by hundreds of patrols, map them onto the arteries of empire, the Bungo Swedo, the Luzon Strait, the Formosa coast, and numbers start telling a story of attrition by design. Early on, many of those numbers betrayed the Americans. Torpedoes ran too deep, magnetic pistols detonated prematurely, contact pistols failed at oblique angles. Later, the same numbers became a metronome of ruin: higher hit rates, fewer duds, faster reloads, better radar ranges, disciplined wolf packs. For Japanese captains and planners, the shock wasn't just the damage, it was the change. A threat that had seemed containable escorts with meager sonar, patrol planes with depth charges, zigzags and blackout suddenly, multiplied into a campaign that knew where you were headed, showed up at night on your bow, and fired not one torpedo but a stitched pattern. The emotional arc inside those convoys is part of the story. First, dismissive, then anxious, then hollowed out by dread as tankers failed to arrive, and shipyards could not replace hulls as fast as black wakes erased them. Zoom back into the control room. The solve is running in metal and sweat. The TDC dials are nudged. The captain keeps one eye on his scope, one hand on the periscope shears, body angled to the faint roll. The forward room reports ready lights. The officer of the deck calls bearings. The plotter draws tidy triangles in grease pencil, the submarine's slow heartbeat syncing with the minute clicks of a stopwatch. Fire. If this were early 1942, we would be bracing for the anticlimax of water slapping back into the tube's mouth and brutal silence where thunder should be. If this is late 1944, we expect a different physics. A rupture in steel and oil, a bow lifting as inertia dies, a second hit at the stern to seal a convoy's fate. The map is bigger than a single sinking. American torpedo wakes radiate out from Fremantle and Pearl, from Midway and Majuro, from the heads of skippers who learned to distrust their ordnance and then learned to trust it again. They stitch across shipping lanes whose names were whispered by quartermasters and logistic officers as synonyms for survival. Fuel out of Borneo, food along the home islands, ore from Manchuria. Each sunk tanker is a grounded squadron. Each freighter scuttled on a reef is a day a factory goes quiet. The people on the surface had an answer to everything but the machine problem. Courage, discipline, zigzag tables, escort bravado, late war suicide torpedoes. The people underwater operated inside a different culture, one that rewarded instruments, calibration, iteration. The gulf between those cultures widens with every reliable detonation. Spirit can keep men at their guns. It cannot manufacture radar sets. It cannot recut a striker head for a contact pistol across thousands of warshots. It cannot back-calculate depth errors and issue new settings fleet-wide. The boats that prosecuted this campaign were the tip of an industrial spear reaching all the way back to testing tanks, assembly lines, and laboratories that revised their own assumptions in the face of humiliating early results. The last wake reaches its target. The detonation is not heroic. It is chemical fact-meeting naval architecture. In the shock's rising bubble, there is a human story that refuses to be reduced. Watchstanders thrown from ladders, engine room crews pinned by broken piping, men making choices in black, rising water. Our script will not avert its gaze from that. But it also won't romanticize failure as destiny. The American torpedo campaign changed because people forced engineering to answer for itself, because commanders kept pressing the attack even after being betrayed by their weapons, because industry learned. The sea keeps its secrets, the math does not. Tonight we start following both. 4:43 a.m. Philippine Sea, 1942. The submarine is perfectly positioned textbook angle on the bow. Target making 10 knots, range a comfortable 1,000 yards. 2 torpedoes fan out, wakes steady as railroad tracks. The first appears to pass directly beneath the freighter. Nothing. The second produces a foamy heave and a sickening pop that feels less like an explosion than a cough. The freighter plows on, and on the submarine's control deck rage climbs the ladder faster than seawater ever will. A third shot, because you have to try, runs deep, vanishing into the dark as if the ocean has swallowed the war. Early in the Pacific War, the United States entered a campaign that depended on torpedoes with a misplaced faith in their reliability. The Mark 14, paired with the Mark 6 magnetic exploder, was a marvel on paper, and a saboteur at sea. Depth settings were wrong. Magnetic pistols detonated prematurely. Contact pistols failed on glancing blows. The silent service didn't just fight the Imperial Japanese Navy in 1942, it fought its own ordnance. Pre-war testing regimes were a closed loop. Torpedoes evaluated in controlled waters, often without live warheads, often in shallow ranges where depth-keeping errors were disguised by pressure conditions. The magnetic exploder, the Mark 6, was an elegant idea derived from predictable changes in Earth's magnetic field near a ship's keel. In practice, the ocean shrugged. Wave slap, latitude, target speed, and manufacturing tolerances conspired to trigger the pistol early or not at all. Meanwhile, The Mark 14's mechanical depth controlled the diaphragm, sensing seawater pressure, and commanding the depth engine was set to a truth that wasn't true. The torpedo ran several feet deeper than ordered, because cramped test tanks and assumptions about flow over the torpedo's body had lied politely for years. The contact pistol, supposed to give a simple smash-and-fire detonation, added insult to injury. At oblique impact angles, the firing pin mechanism deformed instead of sliding cleanly. At straight-on, down-the-throat shots, the pistol sometimes crushed without arming fully. The worst irony: the more daring and geometrically perfect your shot, the more likely your weapon could betray you. Imagine a skipper who fires 4 torpedoes expecting at least 1 detonation. Post-action analysis reveals 2 ran deep, 1 prematured 50 yards short, 1 hit and failed to explode. Multiply that by patrol after patrol, and a pattern emerges. Conceded opportunities, burning frustration, and commanders who in the ledger of their patrols wrote probable hits with the melancholy of someone who knows probability without proof won't feed the war effort. The rate at which torpedoes failed was not a single figure, but a cloud of failure modes. Seen from the air, it was noise. Inside the boat, it was an accusation. The Bureau and the stations that designed and built the Mark 14, divided by Mark VI, were islands of engineering conviction, and in 1942 conviction sounds a lot like certainty. Paper analyses rejected complaints from the field or reinterpreted them as crew error. The ocean, however, is a laboratory that never signs off on your methodology. Submarine skippers, forced to reconcile the two, developed a bitter pragmatism: shoot more fish than theory would require, favor contact settings over magnetic where they had the authority, and close range when radar and night allowed, so that hit geometry could overwhelm fusing errors. In the first act of the campaign, Japanese captains and planners absorbed not just data but vibes. Convoys still arrived, escorts still found few wrecks, and early American torpedo attacks had the feel of gadfly raids rather than throat-closing strangulation. Doctrine and ideology flourish in that kind of environment. Confidence in zigzag routines, in single escort bravado, in the sufficiency of lookouts and blackouts. You can forgive them for believing the underwater threat was manageable. On some routes for some months, it was. The channel you're modeling doesn't flatten this into technical arcana. It shows the human in control rooms across 1,942 talented officers wrestled with whether to risk their crews closing inside escort perimeters for insurance. Shots that might not detonate anyway. Radiomen composed contact reports that sounded like apologies. Torpedomen cleaned and checked mechanisms that might be fundamentally misdesigned. Commanders built entire approach sequences around the expectation of dud performance, like planning to fire extra fish at the stern to compensate for a likely shallow run, or offsetting aiming points to catch luck on the edges of a convoy turn. The American submarine arms identity, its eventual lethality, was forged in the friction of this failure. When your weapons don't work, you either cling to doctrine or you become a scientist in a steel tube. The silent service chose the latter. Patrol reports grew sharper in technical detail. Skippers compared results across boats. Engineers were dragged, at first by data and then by embarrassment, into re-evaluating their sacred cows. It's fashionable to say, spirit wins wars, but in this story, spirit is a stimulant, not a solution. The solution is measurement, iteration, and the humility to admit your models are wrong. Back to that 1,942, encounter 2 failures and a prayer. The escort hasn't noticed. The submarine's captain faces the worst tactical question. Does he double down with more ordnance after 3 failures, or does he preserve his remaining fish for another chance days from now? He knows his torpedoes are not just bullets. They are his only bullets. He also knows he's not just trying to sink a ship. He's trying to prove a case to men in offices far away. He fires one more. Set shallow. Contact. It hits. The sound is not the thunder he wants, but something did break. Maybe a propeller. Maybe a shaft. The freighter slows. Escorts churn toward the disturbance. The submarine slides away into a thermal layer, men listening for props, for the click of fate. This chapter is the part of the movie where the hero's sword shatters. The next chapters are about forging a better blade in the middle of a fight. The Americans didn't fix the Mark 14 divided by Mark VI because they wanted to. Institutions rarely change because they want to, but because their crews produced a body of field evidence that couldn't be denied without denying the war itself. Before we get to the wolf packs and radar magic, we have to sit with the simplest, ugliest truth. Nothing is more demoralizing than doing everything right and watching your weapon shrug. And nothing is more galvanizing than forcing it, finally, to work. Dawn, 1943, somewhere off Solomons. A submarine rises just enough to put steel into water for a test the Bureau told them not to run. The crew has rigged a torpedo with telltales away to sea after recovery, where its steering gear actually took it. They'll fire it across a measured range, then chase it down, drag it aboard like a harpooned shark, and measure truth against orders. It feels like insubordination because it is. It also feels like survival. The American torpedo crisis ended not with a memo but with a mutiny of facts. Skippers risked careers to run unauthorized tests. Torpedomen documented depth errors. Squadron leaders compared dud tallies like epidemiologists. Meanwhile, engineers first defensive, then chastened changed pistols, recalibrated depth mechanisms, and revised magnetic settings. The result was an inflection point. The same boats, the same crews, the same ocean, but now each launch had a far higher chance of delivering industrial consequences. Start with depth. The torpedo's depth engine read pressure, translated it into a command to dive planes and rudders, and believed itself. Field tests using nets, measured ranges, and even live fire into cliffs or shoal areas showed the ugly bias. Torpedoes were running consistently deeper than set. Calibration curves were rewritten. On the boat, torpedomen learned to lie to the settings. If you want 8 feet, set 6. Eventually, the components were corrected so that the lie was no longer necessary. The magnetic exploders theory, detonate beneath the keel to break a ship's back, remained seductive. In practice, latitude and sea conditions made it treacherous. Operational orders increasingly favored contact settings, especially in lower latitudes where Earth's field and equatorial quirks amplified premature detonations. The contact pistol itself was reworked. The striker and firing pin material and geometry revised to avoid deformation on glancing blows and to ensure robust function at direct hits. A culture of torpedo room ritual emerged. Checklists, inspections, replacement of suspect parts, and a new skepticism that treated every component as guilty until proven reliable. Patrol after patrol, the probable hit divided by no explosion, entries dwindled. Hit rates per spread edged up not only because the weapons improved, but because confidence reshaped tactics. A skipper who believes in his fish will fire spreads optimized for geometry rather than superstition. He will take more aggressive end, rounds to earn bow shots. He will risk the surface to reload faster because the torpedoes he's feeding to the sea are actually buying effects. The fleet's aggregate math shifted. Fewer torpedoes per sinking on average, more tonnage removed per patrol day, a better ratio of warshots expended to ships confirmed sunk. This channel loves the moment where an organization stops insisting and starts learning. The torpedo story offers several. The stations that had certified the Mark 14 divided by Mark VI rewrote manuals, produced retrofit kits, and spread the corrected doctrine fleet-wide. Commands acknowledged the evidence, codified new settings, and encouraged more rigorous patrol debriefs. Instructors stopped reproducing the old catechism and began teaching the seamanship of evidence, what to measure, what to log, how to describe a failure mode, so that an engineer in Rhode Island could fix your problem without ever seeing your ocean. As the weapons became dependable, other parts of the kill chain snapped into harmony. Radar ranges could be trusted to feed TDC solutions. The TDC solutions could be trusted to produce gyro angles that matched where torpedoes actually ran. Contact detonations could be trusted to translate geometry into steel failure. This confidence altered the rhythm of the night. Less hedging, more orchestration. Wolfpack leaders could plan staggered attacks without budgeting absurd numbers of warshots for the same ship. Squadron commanders could assign patrol boxes with the expectation of real attrition rather than hopeful harassment. The emotional arc inside the silent service also changed. The insurrection that forced the fix became institutional habit. Question, test, verify. Skippers traded notes across mess tables about best spreads against zigzagging freighters, or about when to ignore magnetic settings entirely. A vocabulary of craft flourished down the throat again, but shallower, swing to catch the tail, and with it a posture that mixed aggression with empiricism. Nothing in this war was ever clean. Some failures persisted, but the curve had bent unmistakably toward function. The Japanese merchant marine and its protectors did not wake up to a new torpedo overnight. What they experienced was a rising tide of catastrophe. Ships that used to limp away after being hit were now breaking. Convoys that had endured night attacks with manageably light damage now lost multiple hulls in a single pass. Escorts arrived to hunt a submarine and found instead rafts and oil slicks. Morale is a resource, not a slogan, and in 1943-44, it was drained not only by the number of attacks but by their completion. A completed attack hit, rupture, fire, sink writes its own propaganda into the minds of watchstanders. Our test torpedo, the unauthorized one, has been hauled aboard. The crew reads its scuffed paint and bent fins like a confession. Depth marks prove the lie they suspected. They log it. They send the report in terms dry enough to pass gatekeepers. Somewhere far away, a drawing is updated. A directive goes out. Weeks later, other boats will notice that a setting of 8 now produces 8. On a patrol a world away, a skipper will line up a tanker and fire, expecting the right physics and getting them. The ocean will not congratulate anyone, but it will allow the math to work. There is a quiet heroism in deciding that evidence is more important than pride. This chapter's drama isn't a gun duel or a desperate dive. It's technicians with grease under their nails proving something that embarrassed powerful people. The silent service didn't become decisive because its captains were braver than anyone else. It became decisive because its culture learned to punish wishful thinking. If there is a transferable lesson here for any complex endeavor from code to medicine to aviation, it is this. When reality contradicts doctrine, reality wins. Choose to help it. A torpedo leaves its tube, and the world compresses to seconds. But the seconds are standing on years. Before that wake ever appeared in a moon-silvered strait, someone mined ore in Minnesota, someone drew a striker head in graphite on vellum, someone set tolerances on a gyro spindle, someone mixed Torpex in a controlled room and weighed its grains like gold. The submarine campaign is dramatic at the tip. Its real power begins in places where drama is a defect. Design rooms, inspection bays, freight depots, and training schools whose product is reliability. The decisive factor behind the silent service's late-war lethality wasn't only courage or clever tactics. It was the American industrial system's ability to manufacture complexity at scale, revise it in flight, and deliver it to far-flung boats in a form that actually worked. This was not a simple "we built more" story. It was, we built, measured, changed, and delivered faster than an opponent constrained by ideology, resource scarcity, and craft over process habits. Think of the Mark series fish as a supply chain wrapped around a physics problem. The body is a pressure vessel with hydrodynamic demands. The engine is a miniature power plant. The guidance is an analog control system. The warhead is chemistry harnessed to a firing train. Each subassembly has failure modes that must be understood, bounded, and kept rare. American factories attacked that with interchangeable parts and statistical control, gauge blocks, go divided by no, go fixtures, inspection records, serial traceability. When field evidence forced changes, depth engine recalibration, pistol redesigns, New settings for magnetic triggers, those changes could be pushed through the same arteries. Revised drawings, modified jigs, training bulletins, retrofit kits, replacement units staged forward. Meanwhile, the inside of the submarine mirrored the factory. Torpedomen became micro-manufacturers, cleaning, testing, swapping out suspect pistols, aligning gyro spindles, purging moisture from air flasks, inspecting sealing surfaces with rituals learned from manuals rewritten in the wake of the early crisis. The difference between a weapon that should work and one that does is usually 1,000 unglamorous acts tightening, logging, verifying. American industry made those acts discoverable and repeatable. American crews made them habitual. The chapter you're emulating loves to take a big, abstract claim and force it to wear numbers. Do that here. Consider the cadence. How many torpedoes a month a single plant could finish? How many pistols per batch were tested to destruction? What percentage of war shots arrived forward with the latest changes? How long it took, measured in weeks, to turn a field finding into an engineering change notice and then into physical parts on a loading pier in Pearl or Fremantle. None of those numbers are romantic. All of them are the bones under the silent service's skin. On the Japanese side of the ledger, genius existed. So did bravery. What didn't exist in sufficient quantity or at sufficient velocity was process tied to resources. Escort ships were limited, sonar sets lagged, radar remained scarce, convoy doctrine matured late under duress. Each of those shortfalls multiplied the power of an American torpedo that now, finally, behaved as designed. An ideology of heroic endurance and frugality, valuable traits in many human stories, can't conjure radar, tubes, oil, or 1,000 identical contact pistols machined to tighter tolerances. It can't relocate ore deposits or rebuild refineries that no longer receive crude because tankers are burning. In this asymmetry, the periscope is an instrument, but the factory is the cause. Consider the choreography required to keep submarines lethal. Forward depots, stockpiled pistols and warheads. Tenders tied up in atolls, turned into floating workshops. Training syllabi updated in near real time. Skippers briefed on the latest reliability advisories. A boat arrived from patrol, offloaded its duds and its dead reckoning stories, and took on new fish with revised innards. Within days it sailed back out carrying not only ammunition but the latest state-of-the-art, a state that was weeks or months ahead of what its adversaries expected, because information moved at industrial speed up and down the chain. It's easy to treat the torpedo alone as the hero, but the torpedo's hit rate is only as good as the upstream instruments. The analog TDC brass, gears, cams, was the physicalization of differential equations. It required manufacturing skill usually reserved for watches and artillery sites. It demanded that boats across oceans share not just a design, but a quality level. The SJ radar's range and reliability depended on vacuum tubes and waveguides, whose production demanded consistency across thousands of units. These were not one-off artisan triumphs. They were the victory of interchangeable precision multiplied. Training is a kind of factory. It takes raw volunteers and produces torpedomen, radarmen, quartermasters who can turn sensor returns and speed lines into hit probability. The U.S. submarine force designed its training around feedback loops. What patrols report, schools teach. What schools teach, boats do. What boats do, manufacturers adjust for. That circuit combat lesson redesign redeploy ran faster and cleaner in 1943-45 than the Japanese system could manage, in part because Japanese institutions were busy surviving air attack and resource strangulation, and in part because centralized insistence on doctrine damped field to factory feedback. If you want the audience to feel the industrial argument in their gut, translate it into waterline effects. When a tanker fails to arrive, calculate the aircraft that don't fly. When an escort carrier lacks a full anti-submarine screen because shipyards are repairing hulls instead of launching new ones, tally the convoys that are now more exposed. When a submarine squadron logs fewer duds per patrol, Convert that into propeller shafts, twisted, beams buckled, minutes it takes for a ship to go from hit to gone. It isn't that 15,000 torpedoes is a boast. It's that 15,000 attempts backed by factories that listened produced enough completed catastrophes to starve an empire. Picture a submarine moored to a tender in a lagoon whose map coordinates were classified even from storms. Cranes swing warheads aboard. Machinists on the tender's deck rework pistols under canvas to keep salt out and secrets in. A radar technician swaps a suspect tube and scribbles a serial in a notebook that will become a statistic. The skipper briefs his heads of department. New settings recommended for magnetic triggers at the latitudes they'll patrol. New defect advisories for a batch of tail cones. New doctrine on firing spreads against zigzag patterns observed near Formosa. None of this is cinematic. All of it is war. Your competitors' scripts land because they connect moral weight to mechanical truth. This is one of those places. Industrial power is not morally neutral. It's morally dangerous. It can turn the sea into a mass grave with brutal efficiency, but it can also shorten wars by making outcomes obvious to decision-makers who would otherwise cling to delusions. The submarine campaign's factory backbone did both. It multiplied tragedy in the 6Gs short term and made denial expensive in the long term. There's no clean way to celebrate that. There is an honest way to look at it. When a torpedo leaves a tube on a quiet night, the universe of its fate has already been narrowed by people the camera never shows. If a tanker erupts into flame 10 seconds later, credit a chain of choices that values measurement over myth, reproducibility over rhetoric. If it runs deep and vanishes, blame the same chain failing. In this story, the silent service is silent not because submariners are modest, but because engineering tends to whisper until it explodes. The rest of this series will keep one ear on the whisper and one on the blast. 2311. Luzon Strait. Overcast. Sea State 3. A submarine rides the swells on the surface, diesels straining as the captain executes an end around. The convoy is to the west. Black silhouettes against a duller black, zigzagging on a routine that a patient hunter can predict to the minute. The plot table is a geometry classroom lit by red lights, bearing drift, relative motion triangles, knots converted to yards per minute. A stopwatch hand advances, a pencil ticks, a man breathes through his mouth so he won't fog the eyepiece. The order that will matter isn't fire, it's spread 4 3-degree separation, 0 + 3 - 3. That's not poetry, that's probability. The US Prime submarine campaign did not win by daring alone. It won by turning combat into a solvable math problem, then solving it thousands of times. A force that rarely exceeded 2% of Navy manpower sank a wildly disproportionate share of Japanese shipping because it treated every patrol like a rolling experiment in hit probability, every salvo like a distribution curve. The culture that emerged skeptical, data-hungry, disciplined took fragile pieces, uncertain estimates, fickle seas, human stress, and stacked them into advantages. Start with the kill chain broken into variables. Detection, radar range and sea clutter. Interact with target size and aspect. Approach, relative speed governs whether you can achieve a zero bearing rate shot. Your periscope's target bearing stops sliding. Solution, the torpedo data computer, TDC, ingests own ship course and speed, target course and speed, and desired gyro angles. Execution, you do not fire one fish. You fire a pattern calculated to bracket your errors. Each variable's uncertainty can be estimated. The skipper's job is to reduce those uncertainties where possible. Close range at night, use radar to stabilize speed estimates, wait for the convoy's zig to align, then smother the remaining uncertainty with spreads. On paper, an ideal firing solution uses one torpedo. In the ocean, chaos taxes perfect solutions. So the solution shifts. You buy hit probability with 2, 4, 6 torpedoes, all aimed not at a single expected track, but at the space a ship's hull is likely to occupy across a few seconds of motion. You set depth slightly below the keel of a tanker, slightly above for a small freighter. You bias the pattern for the ship's tendency to turn toward an escort when it senses something. You account for environmental layers that might slow or accelerate the run. Average shots per sinking is not a footnote, it's a heartbeat. Early in the war, that number was shameful. High shots per confirmed kill, because duds and deep runners ate spreads like gulls eat bread. As reliability rose, the ratio tightened. Patrol reports began to show patterns. 4 fired, 2 hits. 6 fired, 3 hits. Meanwhile, the search portion of patrol days, empty ocean, empty scope, compressed as intelligence and radar improved. A patrol might last 45-60 days. The boat might be in contact fewer than 10. What decides the war is what you do in those narrow windows. The silent service learned to compress setup time, to move from first radar paint to firing solution in minutes, rather than a long hour. That speed is math turned into muscle memory. The chapter your competitor would write here is a compact, why it worked box. So let's put one in your voice. Why a spread? Because every estimate hides bias. Target speed is guessed from bow wave and bearing rate. Angle on the bow is inferred from silhouette. Your TDC solves continuously but based on that original sin. You could be off by a knot, by 5 degrees. A spread acknowledges that you are human and that the ocean moves. You fire the center torpedo at your best solution. You fire sisters that shade left, shade right. You time them to create a bead curtain a hull cannot slip through. You think not in single lines but in rectangles of fate. After an attack, reload speed is a quiet determinant of strategy. A trained crew can cycle tubes in minutes, but under depth charge threat, in jostling seas, with damaged airlines or finicky shutters, minutes stretch. Boats that could reload fast could press a second attack before escorts organized. Multiply that capability across a wolf pack, and the convoy's survival curve bends sharply downward. So the math isn't just in the water, it's in the boat, standardized drills, torpedomen who speak in seconds, not generalities. The ocean is big. Ships take roads. Patrol areas were not random rectangles. They were volumes defined by choke points, seasonal currents, and traffic intelligence. The Luzon Strait, the Bungo Swedo, the approaches to Formosa and the home islands, these are funnels that concentrate probability. A single boat free hunting in the Philippine Sea might see nothing for 2 weeks. That same boat assigned to a funnel, backed by decrypts or traffic analysis, might see 2 convoys in 3 nights. The math here is simple. Maximize time in funnels, minimize time wandering. That is not glamorous. It is decisive. What does this feel like from the convoy's bridge? First, you notice the attacks seem unnervingly lucky. Ships are not nicked, they are bracketed. Escorts dash toward one wake and collide with another. Tankers, the meat of a nation's war diet, take hits not randomly but at weak points. Under the stack, forward of the engine room, just aft of midships where fire spreads fastest. If you survive an attack, you find that the submarine appears again after a tense hour, like a wolf that trotted ahead on the trail and now waits. One boat acting with arithmetic can feel like 3 to someone living inside the crossfire. In our end, around, the captain chooses his moment. Range under 1,500 yards on ahead, on course that will allow a sharp turn after the salvo. Set spread 3, center on the lead tanker. The forward room breathes. Tubes clack. The TDC operator watches the solution stabilize. When the button goes, it's not magic. It's the culmination of angle arcs, stopwatch laps, and a chest of habits built on the failures of 1,942. 2 impacts, then a third further back. As a ship, a column over blunders into a torpedo that was wasted on insurance. There is no such thing as waste when you are buying probability on credit from the ocean. The math isn't romantic. It's a discipline that frees courage to matter at the right time, in the right place. If there's a single lesson to carry out of this chapter, it's that warfare at sea, for all its spray and chaos, rewarded the boats that treated uncertainty like a bill to be paid. not a mystery to be endured. The silent service didn't eliminate chance. It outvoted it. Dusk, off Formosa. The sunset is a bruise. On the eastern horizon, smokestacks draw charcoal lines across the sky. Tankers round-bellied, escorted by nervous little teeth, push north. The submarine waits not where they are, but where they must pass, in a ribbon of water whose currents are treacherous, but whose geography is fated. The skipper knows it, the way a hunter knows a game trail. He doesn't need to see the entire empire. He only needs to block one artery at a time. The submarine campaign wasn't nuisance raiding. It was a designed commerce war that identified Japan's circulatory system oil from the south, ore and food along the ring, coastal shuttles between home islands, and applied repeated, concentrated shocks. The cumulative result was starvation in factories and flight lines, long before bombs fell on them. Tankers lit in the night are not isolated tragedies. They are blackouts for aircraft squadrons months hence. Japan's industrial machine lived on imported oil. Tankers from Borneo, the Netherlands, East Indies, and other southern fields pushed through choke points where deep water narrowed. Straits near the Philippines, channels along Formosa, the Bungo Suido, the approaches to the inland sea. Freighters carried coal, rice, bauxite, machine parts along coastal lanes that ran close enough to land for navigational comfort, close enough for ambush. The U.S. submarine force mapped these routes as a network. Intelligence from decrypts and reconnaissance painted convoy schedules with enough clarity that boats could be stationed like valves to constrain flow. Choke points are where small forces can matter. A single boat cannot shut an ocean. 3 boats, stationed across a night's worth of water in a strait, can gut a convoy so badly that even if half the hulls limp through, the loss rate bleeds the system. Wolfpacks work not by swarming in chaos, but by time-sharing. One attacks, others slide into lanes, rifles down. Then, an hour later, positions switch. The convoy can't sprint forever. Escorts can't be everywhere. Start with tankers. Each one holds aviation fuel the way a lung holds air. A sunk tanker is not just tonnage. It's fighter sorties that won't be flown, training hours that won't be logged, ships that won't leave port for lack of bunker fuel. Translate one night's work, 2 tankers down, one crippled into a month's effects. Squadrons grounded for 5 days here, training cancelled there, transport runs rescheduled with smaller loads and bigger risks. Build the graph month by month, tanker arrivals versus needs, and watch it slope into crisis. Then add freighters burned along the coast. Every freighter you send to the bottom while loaded isn't just steel removed. It's a factory that ordered parts that won't come, and workers who show up to idled machines. The commerce war alternated between patience and fury. Patience. Long hours listening, radar sweeping empty space, conserving batteries and fuel. Fury. When contact comes, a stack of rehearsed actions unspools. Contact report, approach, salvo, reload, reposition, maybe surface to use the deck gun against a straggler if escorts peel off. Then patience again, because the point isn't motion, it's interruption. A convoy that dares not sail at night is a win. A shipping ministry forced to reroute around your patrol lines adds days to transit. Days mean fewer trips per month. Fewer trips mean production schedules slip. The arithmetic is gentle and ruthless. As losses mount, routes hug coasts tighter. Coastal waters feel safe because they promise air cover and quick refuge in inlets. They are, in fact, a trap. Navigation becomes predictable. Depth readings rise. The range of angles from which a submarine can attack multiplies. Mines appear, escorts seed channels, patrol planes drop flares at hints on the water. The commerce war becomes a chess game played on a smaller board, with sharper teeth on both sides, casualties higher when pieces meet. The silent service learned those coasts like habit, where to lie in the lee of a headland, where currents folded sound and let you slip under a convoy, where the bottom rose so quickly that a careless depth charge pattern would be wasted. Early torpedo unreliability gave convoy commanders a false sense of proportion. When the torpedoes began to work reliably, the same tactics produced finality. Ships that had once been nicked now died. Meanwhile, radar and wolfpack coordination improved the odds of finding and fixing convoys. Japanese adaptations, more convoys, more escorts, tighter formation discipline, stiffened resistance but also concentrated targets and made valve tactics even more potent. Escorts get better at hunting, submarines get better at slipping into thermal layers and approaching on the surface like destroyer shadows. The dance intensifies, but the dance floor remains the same narrow straits. Numbers win there. Commerce war is not glamorous even when it works. It is long hours of waiting to commit brief acts of violence against men who are not pulling triggers but pulling watches on merchant bridges. Men whose deaths will never have parades. Your competitors' scripts would not flinch from showing that. Neither should you. A tanker ignites and paints the sky with a filthy dawn. In that light, a lifeboat pulls away, crowded, faces turned toward a dark horizon where the submarine has already gone. If the camera lingers, it isn't to revel, it's to remind. Strategy is made of these minutes. Our ambush at Formosa unfolds with cruel logic. The convoy's lead escort jogs to investigate a wake spotted late. That jog creates a seam. A boat slides into that seam and rips open the convoy's front rank. Smoke blinds lookouts. Another submarine, stationed like a catcher, takes a shot at a fleeing tanker and punches through the stern. The convoy's speed drops as traffic piles up in panic. More minutes pass than anyone thinks possible. In those minutes, a nation's fuel budget melts into the sea. The commerce war's verdict is rendered in factory silence machines idle. Officers send curt messages up chains of command. Ration schedules shift from unpleasant to impossible. People far from the sea begin walking instead of riding, or eating fewer bowls of rice, or wrapping themselves in coats inside cold rooms. At sea, the submarines are already somewhere else, hunting a different artery. They do not see the men who will be hungry months later, but those men will feel the wakes just the same. Noon, inland sea. A training escort circles with almost lazy confidence, throwing a pattern of chalk practice depth charges for the benefit of young sonar men. The reports roll back from the hills like thunder in a summer canyon. The instructor points at a blackboard with grease-penciled zigzag schedules and convoy station diagrams. The lesson's subtext is simple. Keep formation, trust your ears, trust your courage. Out beyond the training range, real convoys move with the same faith. Japan did not fail to notice submarines. It failed to correctly update its threat model when the American wolf learned how to bite. Overconfidence born in the Mark 14 dud era, doctrinal inertia, industrial shortages, and an intelligence gap combined to create a lag months, then critical years between what was happening at night on the water and what institutions were willing and able to correct by day on land. Start with escorts. Not enough hulls, not enough sonar sets of consistent quality, and late deployment of specialized anti-submarine warfare, ASW platforms. Add radar scarcity, night surface attacks favor the side with eyes in the dark, and the Americans brought radar to sea as standard as a periscope. Add training time. As losses mount, green crews replace veterans faster than schools can imprint hard-won lessons. Add fuel. Escorts cannot drill, convoys cannot weave, aircraft cannot patrol without burning the resource the submarines are already strangling. Doctrine sits at the center. Early American torpedo failures taught the wrong lesson. We can handle this. When the Americans fixed their fish, Japanese convoy habits, speeds, formation densities, response patterns remained anchored in an old reality. The ASW art is dynamic. Your adversary's data belongs in your doctrine. Instead, Japanese practice relied on spirit and repetition more than on field-driven revision of patterns. Zigzag tables grew stricter. Escorts grew more aggressive, but the big determinants routing, numbers of escorts per convoy, radar ubiquity, sonar quality lagged behind need. The submarines did not wander. They hunted based on traffic analysis and decrypts that turned oceans into calendars. Even when code-word intelligence was imperfect or compartmented, the culture of American operations prized synthesis. Reports from one patrol's success or failure fed into the next week's assignments. Japanese counterintelligence and operational security had strengths, but their radio discipline sometimes leaked enough to shape American ambushes. Convoy schedules, when predictable, become a file of appointments death keeps. It's easy to say they should have known, with charts that slope down. Inside the months themselves, the signal is dirty. A convoy escapes here, another gets hit but limps in. A new escort tactic appears to work in one strait, but fails in another. The question isn't whether Japanese commanders saw submarines as a threat. It's whether they could translate perception into resources. You cannot conjure radar sets or sonar domes from slogans. You cannot crew escorts with men you do not have. The metrics that matter: escorts per convoy, radar percentage, average ASW air hours per convoy leg, moved in the right direction late and too slowly. People prefer to fix familiar things. If your doctrine says tighten formation and add a leading screen, then you will advocate for training that perfects that art, for courage that doubles down. If your real problem is that submarines are seeing you from 10 miles away at night and setting up end-arounds you never detect, then courage will not help. New technology would. New technology requires industry at scale. Industry requires fuel. Fuel requires tankers that keep getting sunk. That circular dependency, once established, is as cruel as any ambush. For merchant captains and convoy officers, the shift from handled to hopeless felt abrupt. The night surface attacks grew more precise. The number of torpedoes in the water at once grew. The second attack an hour later became routine. The ocean did not change speed. The submarine did. Its eyes reached farther. Its math got tighter. Its crews expected their torpedoes to explode. That last piece might be the most psychologically devastating. Your enemy stops wasting his chances. You, meanwhile, are asked to do more with less same routes, fewer escorts, tighter fuel budgets, louder skies filled with other wars. The instructor has updated the board. There is a new lesson on night radar contacts, a new emphasis on air escort handshakes, a new admonition to vary zigzag rhythm irregularly. But the equipment count hasn't changed much. A few sets have arrived, some are temperamental. Pilots get fewer hours because fuel has gone to the army. The young sonar men listen harder. Listening harder is not the same as hearing earlier. By the time the institution fully absorbs the magnitude of the submarine threat and adopts more convoys, more escorts per convoy, and better ASW air cover, the strategic environment has worsened. Industrial bombardment begins in earnest. Shipyards repair instead of launch. Mines snarl coastal lanes. Training pipelines thin. Improvements shave percentages. Submarines shave hulls. Attrition is arithmetic baked into time. Victory goes to the side whose learning loop closes faster. In this contest, it wasn't close enough. The temptation in hindsight is cruelty, to sneer at the slow learner. Resist that. Replace sneer with clarity. Systems under stress cling to familiar rhythms until those rhythms kill them. Japan's maritime system wasn't blind. It was trapped. By prior success that taught the wrong lesson. By doctrine insulated from embarrassment. By an industrial base that could not pivot fast enough. The submarines did not just sink ships. They sank the delay between reality and admission. That is what felt on the bridges of convoys and in the offices of shipping ministers like Shock, 142, overcast, slight drizzle, perfect radar weather. The submarine rides high on diesels, bow wave whispering. Inside the conning tower, the radar scope shows a faint smear that steadies into a line. Range 12,000 yards, bearing steady left. The captain's voice is low, ritual calm. He asks for the TBT on the bridge, the target-bearing transmitter, to verify line-of-sight bearings for the TDC. One crewman keeps his eyes in the eyepiece. Another keeps his on the grease pencil range marks. In this cramped cathedral, antenna rotation and cam rotation are the liturgy. The boat closes like a rumour. Technology didn't replace seamanship, it amplified it. SJ radar, TBTs, and the TDC turned night into a laboratory where disciplined crews could run experiments, contact, approach, solution at ranges and speeds impossible by eyeball alone. The result was a new class of predator, the night surface attacker whose periscope might stay dry until the last minute, whose firing solution matured in the conning tower while the enemy slept on routine. Start with SJ radar. It doesn't paint shapes, it paints certainty that something metallic and sizable is out there, how far, and in what direction to your own bow. Range rates tell you speed, bearing drift tells you course. Because you can track over minutes rather than the seconds a periscope dares show, your estimates become measurements. That's the crucial shift. You move from guessing to knowing enough. Feed those measurements to the TDC. This analog computer is a box of cams, gears, differentials that perform trigonometry with brass and oil. It doesn't solve once, it solves continuously. If your estimate of target speed tightens, the cams adjust. If your own course changes during the approach, the machine compensates. You can watch a solution stabilize like a heartbeat calming after a sprint. When it's calm, you don't need luck. You need timing. The TBT up on the bridge is a humble hero. It lets a lookout or officer train an optical sight on the target and transmit that bearing directly to the TDC below. In heavy weather or at critical moments, when radar clutter lies or the periscope would betray you, a TBT bearing verifies or supplements the picture. On some nights, the TBT is the last honest voice when electricity sulks. With radar as eyes and TDC as brain, the submarine turns into a torpedo cruiser after dark. On the surface, you are faster and more maneuverable than submerged. You can perform rounds that reappear like magic on the convoy's bow. Escorts without radar are blind wolves. Escorts with radar but poor doctrine are noisy and confused. The submarine's approach is a series of quiet corners. Cut inside the outer screen, present a narrow profile to the few escorts that matter, and appear where the convoy's own motion gifts you an angle of impact that advantages your spread. Radar range: 10 miles and change for first contact in good conditions, 5 to 7 for steady tracks in middling seas, 3 for reliable bearings that let the TDC hum. Target speed: 8 to 12 knots for many convoys, slow enough that a surfaced sub can run around them at 15 to 17 knots, depending on sea state. TDC solution time: minutes if the ranges are steady and the approach geometry is favorable. Torpedo run time: a minute or two at typical salvo ranges, during which your boat can already be turning away to present a stern that steals you back into the night. Technology isn't one-sided. Escorts with radar change the calculus. Aircraft with radar and flares make night surface approaches more dangerous. The submarine adapts. Use thermal layers to hide if forced down. Time approaches against rain squalls and horizon clutter. Prefer periscope depth when a radar picket is confirmed. Fire from just under the skin when necessary and accept the reduced mobility after the shot. The TDC still earns its keep here. Submerged, it continues to compute so that short periscope exposures 5 seconds, then down are enough to refine a solution. Instruments don't win unless people do the wiring, not just the cables, but the mental habits. Radar operators must learn to separate sea clutter from small escorts, to recognize when a target's course change is real or just an artifact of your own maneuver. TDC operators must trust the machine enough to avoid over-tweaking and distrust it enough to cross-check with independent bearings. The captain must choreograph this while keeping periscope exposure seconds to a minimum and while planning exit routes in case an escort guesses right. The crew must absorb new procedures without losing old instincts. Smell for diesel smoke on the wind, feel for the change in a wake slap when you've turned too close. Listen to the engines the way a drummer listens to a band. Your competitor would write a paragraph here with restrained fireworks. Let's do it. On a good night, the radar paint enters, steadies, stretches as range falls. The TDC's lurches smooth out into a clean crawl. The bridge keeps the TBT pointed where the machine wants and where their eyes agree. The boat slides into the slot between two escorts because math says the slot exists. The captain gives the order with nothing in his voice. Tubes breach, wakes stitch, and the convoy learns that the knight it trusted is a partner who lies. There is no cheering. The boat swings away, already thinking about the second act, another end, around, another lane. The men who do this work sleep in rotations that never quite catch up. Once night surface attack became standard practice, convoy commanders faced a choice: slow down and hug coasts to force submerged approaches, or speed up and accept that the wolves will run around you anyway. Both choices bleed you. Time is cargo you lose. Speed is fuel you do not have. As more submarines carried radar and crews matured on TDC skills, the night became American water by default. Japanese doctrine that had treated darkness as ally now had to treat it as threat. That reversal, the moral blow of losing the night, is hard to quantify and easy to recognize in the way reports grew cautious, in the way formations tightened until one hit became three. Our drizzle night turns to rain. The radar paint grows fuzzy at range and clarifies as the submarine noses into the weather. The TBT operator has rain streaming into his collar and never moves the sight off the tanker's imagined place. The captain calls for final bearing. The TDC murmurs numbers in metal. The boat becomes, for 3 seconds, a platform that exists only to empty its tubes accurately. After the flashes, the rain swallows the evidence. The escort that sprints toward the spreading glow chases a ghost. Radar loses clutters. The submarine becomes sea again. There is a kind of romance in instruments done right, not the romance of gadgets, but of human beings deciding to let precise tools teach them humility. Radar, TBTs, and the TDC are at their best when no one is grandstanding, when the operator says steady contact and the captain says, I believe you, and a nation's strategy moves forward one invisible sweep at a time. The Night Stalkers didn't just master darkness, they mastered attention. 23:58, Kuroshio Edge. The sea is oil dark but restless, wind shouldering white from wave tops. A convoy's phosphorescent wakes make a faint stitched ribbon, visible only from the height of a conning tower if you know what you're looking for. The lead submarine radios a brief contact in clipped code and then goes quiet. 2 other boats, already running a wide arc ahead, adjust courses like chess pieces you can only feel with your fingertips. No one says, Wolfpack, but that's what this is. Patience coordinated. American submarines began the war as lone stalkers and ended it as coordinated hunters. The evolution night surface approaches, end-arounds, pack tactics. Submerged finishers took a force that was small on paper and made it large in effect. Tactics didn't just add together, they multiplied. Radio is a double-edged knife. Talk too much and escorts triangulate. So doctrine paired communication to the bone. A first contact report, bearing course, speed, convoy size, a shadowing update at intervals, and then pre-briefed plays. The leading boat stayed outside starshell range, pinning the convoy's course. The outriders sprinted on the surface to cut ahead and cross the bow. One attacked, drawing escorts and light. The next slid in from a different axis as the convoy instinctively turned toward confusion. If conditions forced the hunters down, they finished submerged, letting the torpedo data computer sip bearings from short periscope peaks. A single sub can end around a convoy, but doing it in company changes the math. While one boat is reloading or evading depth charges, a partner is already ahead. Average time between salvos against the same target set drops from hours to minutes. Escorts, short-legged and fuel-hungry, struggle to maintain a 360-degree umbrella when threats appear in scheduled waves. The convoy's only reliable counter is speed, which burns fuel the system can't spare, or radical route changes, which add days the Empire can't afford. Pack doctrine standardized seams. Small windows in space, time where an attacker could meet a convoy between escorts' patrol arcs. Boats learned to see those seams forming when a screenship surged to investigate a wake, when an air patrol peeled off for weather, when a zig unbalanced spacing and to treat timing as a weapon. One submarine might deliberately waste the first torpedo of a salvo to fix a column's attention, left, then punch the real pattern into the blinded right. You're not trying to win a duel with an escort, you're herding a flock into your crosshairs. Packs cut the effective convoy survival probability sharply. Instead of one attack per night, convoys suffered 2 or 3. Torpedoes per sinking fell as crews learned where to aim for guaranteed mobility, kills propeller shafts, engine rooms, under-tank sections. Reload times on well-drilled boats collapsed to minutes when seas allowed. A 60-day patrol that might once have logged a single confirmed sinking now returned with multiple tankers and freighters credited, and an untidy list of probables that were often, in truth, graves. Packs did something lone wolves rarely could. They took away the convoy's belief that surviving the first flurry meant daylight safety. An hour after an attack, just as escorts breathed and survivors thought about planks and prayers, another periscope wake arrived from a new bearing. Confidence is a budget. The pack helped spend it faster. Tonight, the lead boat fires first and draws a picket destroyer far to port with a bright, noisy chase. That tilt opens a seam. The second boat, already on the bow, threads it and slams a tanker in the forward third. Fire blossoms, escorts pivot, horns wail. The third boat has been idling outside gun range, blacked out, men whispering. It slides into the gap where panicked helmsmen have tightened columns until they're practically a single hull. One spread and the whole line stumbles. In 20 minutes, the sea takes back 3 ships and any illusion that the night belongs to the surface. Pack tactics weren't about bravado. They were about turning a few variables, time, bearing, speed into a machine that shows up as inevitability. If one boat is a hunter, 3 boats are a season. A grey morning off Shimonoseki Strait. The submarine watches from periscope depth as small craft move with a purpose that signals something new. Shore, stations chatter. A patrol plane cuts a shallow arc and drops a buoy that pings like a heartbeat. The hunter tastes for once what it's like to be watched properly. Japan countered with everything it could marshal. Heavier convoying, more escorts, radar in limited numbers, air patrols from escort carriers where possible, dense minefields in choke points, and, late in the war, Caton-manned torpedoes meant to turn devotion into guidance. These countermeasures raised costs and forced tactical refinements, but they could not reverse the arithmetic of a fuel-starved, industry-pinched defense. Convoys grew larger and tighter, escorts drilled to lay pattern attacks faster. Coastal routes were mined to deter surface approaches and funnel subs into predictable channels. Aircraft with radar extended night reach, and when escort carriers were available, their circle of steel in the sky complicated end-arounds. Caton units trained to ride piggyback on conventional submarines, detach near crowded lanes, and steer a human brain toward a steel hull. Mines worked bluntly and without heroics because they shrink maneuver space and punish aggression. Air patrols worked when fuel and airframes were available, forcing more submerged approaches that cost the attacker speed and flexibility. Depth charge patterns improved, and some convoys fought off first attacks with a crispness missing earlier. These wins mattered locally and emotionally. They did not scale strategically. Mines are static. Sub-doctrine adapts. Air patrols are hungry. Fuel was rationed by a maritime economy already bleeding. Escorts spread thin cannot be strong everywhere. Turning volunteers into guidance systems reveals courage and desperation in equal measure. Against a stealthy target like a submerged submarine, chiton were mostly irrelevant. Against surface fleets and anchorages they could surprise, but they consumed scarce submarine hulls to deliver short-lived terror. The logic behind them sacrifice, to make up for shortfalls in sensors, platforms, and fuel admits, implicitly, that the industrial race was already lost. Countermeasures increased American submarine losses and inflicted damaged patrols that limped home. But tonnage graphs and tanker arrival charts kept bending down. Even as escorts improved, convoy sizes grew, which meant that when an attack pierced the screen, more value sat within reach. Minefields forced some boats to stand off, yet also created predictable traffic corridors the patient could exploit. Each Japanese improvement shaved percentages off losses. American adaptation and persistence put those percentages back on with interest. Submarines adjusted, more cautious periscope exposures, meticulous sound discipline, habit of letting one boat take the noise, while a partner crept in silent, periscope depth firing when radar-equipped escorts prowled, deck, gun use curtailed unless isolation was perfect, patient, multi-night stalking of high-value tankers, even when mines and patrols made the geometry miserable. The doctrine never confused aggression with recklessness. If the counterpunch forced the hunter to fight 3 careful rounds instead of 1 flashy one, fine. The goal was still the ledger. The periscope's image trembles as the boat slides over a suspected mine line at crawl speed. The captain holds for a patrol plane to pass. The hydrophone whispers about screws to starboard. The sub chooses distance over drama and follows the convoy for a second night, when weather will smear radar. Before dawn, in rain and chop, 2 torpedoes strike a tanker's belly. Mines and aircraft had bought time. Time, in a strangled economy, is not neutral. It is empty tanks and grounded wings. Japan's countermeasures deserve respect for the competence they sometimes achieved and the bravery they often required. Respect does not change outcomes. When the currency of defense is fuel and factories, tactics can only spend what strategy earns. War can be told in scenes. It is decided in sums. Imagine a chalkboard in a submarine tender's wardroom. Columns, patrol days, contacts, torpedoes expended, ships sunk, tonnage by class, probables, ammo left. The board is ugly smudges, arrows, corrections, and that's the point. This is not myth. It's accounting. By war's end, US. Submarines had fired on the order of 15,000 torpedoes and erased a decisive share of Japan's merchant marine, including a critical fraction of its tankers, at a cost far smaller in men and materiel than any other major arm that could have achieved the same effect. Cost-effectiveness is an uncomfortable phrase when the cost is human, but strategy must count. Start with torpedo math. Early war dud rates inflated the shots per sinking ratio. Mid to late war reliability fixes brought that ratio down. Apply those ratios to the long campaign. Each confirmed sinking is not merely a number but capacity removed. Tonnage you cannot simply will back into existence. For tankers, the leverage is extreme. One hull sunk can mean many squadrons' worth of sorties denied across weeks. For freighters, it is factory inputs and food, measured in assembly lines gone quiet and kitchens gone bare. Submarines were expensive to build but cheap to risk. Small crews, long endurance, and the ability to focus violence precisely. Strategic bombing could and did crush industry, but at vast cost in aircraft, fuel, crews, and collateral destruction. Surface fleet actions wrote history in spectacular days. Submarines wrote outcomes in patient nights. The ledger favors what denies the enemy the ability to show up, not just what punishes him for showing up. There is a temptation to treat tonnage as abstract. It is not. Each mark on the board stands for a ship with men aboard, for a company and a port and a family. Counting doesn't erase that. It insists on it. The submarine campaign's morality is complicated. Many targets were armed or escorted. Many were not. Some carried soldiers. Some carried rice. A few carried prisoners whose presence attackers could not know. The ledger refuses neatness. It also refuses sentimentality that would ignore cause and effect. If you want the bombing to stop and the fleets to shrink, you cut the fuel lines. That is what this column of numbers, added to itself night after night, did. Count the unlaunched convoys, the ones cancelled because too few tankers remained or routes became uninsurable even in wartime terms. Count the hours escorts could not train because fuel went to last-ditch ground fronts. Count the aircraft missions scrubbed for lack of aviation gas. Count the factories that shifted from production to repair after submarine-caused attrition, forced shipyards to triage. The ledger captures events, the margin notes capture transformations. The tender's chalkboard is wiped and rewritten as new patrols return. The pattern holds, tighter each month. A young officer, pencil behind his ear, runs a fingertip down the tanker's row and whistles without pride. He knows what these marks mean. He has seen the lifeboats. He makes the next assignment anyway. The numbers don't ask for permission. They only ask to be done right. If there is a single image to carry out of this chapter, it is not a sinking. It is a nation of islands turning toward its ports and finding fewer ships than none. The ledger is not glory, it is gravity. Night ends slowly on a submarine. Lights come up in stages. Voices lift. Coffee scrapes into cups. After patrol, the boat ties to a tender. The crew walks on legs that remember the sea, and silence settles in the stories they don't tell. Victory feels less like a cheer and more like air returning to a room. The submarine campaign achieved its strategic aims, but the wake it left contained more than oil and timber. It held human trauma, ethical knots, and lessons about institutions that outlived the war. Merchant, sailors, Japanese and others died at frightening rates. Submariners died at rates the cheerful recruiting posters never mentioned. Survivors floated under skies lit by their own cargo. Rescue was sometimes possible, sometimes suicidal, sometimes denied by orders that subordinated compassion to stealth. Post-war, men who had listened to screws in the dark struggled to sleep within walls. Others could not board small boats again. Every confirmed sinking in a patrol report is an epitaph written in operationalese. Commerce raiding is sanctioned by the laws of war. That neat sentence does not make decisions neat. Crews faced moments when a burning ship's raft drifted near a surfaced submarine reloading. Pulling even one man aboard could endanger the boat or betray position. Leaving him meant living with the knowledge. Some captains recorded these moments in clinical tones, others not at all. After the war, some found absolution in the argument that strangling capacity shortens wars and therefore saves lives in aggregate. Others wanted no absolution and asked for none. The silent service carried forward a culture. Measurement over myth, ruthless debriefs, humility in the face of the ocean, speed in turning field evidence into engineering change. Those habits migrated into peacetime submarines, into the next generation's sensors and reactors, into a doctrine that still treats a quiet, precise boat as the sharpest tool in a strategist's drawer. The other side's lesson is just as real. Courage cannot pay the bills that industry writes. Cinematic battles often steal the spotlight. Yet this campaign's power lives in less photogenic frames, radar scopes, grease-penciled plots, a torpedoman's hands black with graphite and oil, a machinist mate's ear tilted to an engine's pitch, an escort sailor staring into a night that used to feel protective and now feels haunted. When we tell it right, we don't varnish numbers into triumph. We invite the audience to hold two truths: that the submarine war hastened an end many people needed, and that it did so by sending many others into the sea. A museum. Decades later, a boy stands under a submarine's battle flag, stitched with silhouettes of ships. His grandfather doesn't point to the rows or explain the codes. He points to a brass plate from a torpedo room and says only, "People made this right, and that mattered." Outside, gulls heckle the water. Inside, the air smells faintly of oil and old paint. The boat is quiet in a way it never was in war. Quiet is what the campaign bought. Finally, quiet factories unbombed because they died of thirst. Quiet harbours whose traffic never left. Quiet after-action rooms where the last chalk mark has faded. The ocean forgets quickly. Nations forget slowly. Families not at all. Write the ending without drum rolls. Close the periscope, secure from battle stations, and log one last line. We fired what we had, learned as we went, and the sea kept the rest.